Hi, in this video, a correlation analysis is going to be introduced. The correlation analysis investigates the relationships between variables. Then, it presents two things. One is direction, and the other is the size. In correlation analysis, the most typical method is the Pearson correlation analysis. When we simply say just correlation analysis, by convention, it automatically indicates the Pearson correlation analysis. But when you need a non-parametric alternative, then the Spearman-Rancoder correlation analysis, or more simply, Spearman correlation analysis, is the method. The Kendall's W test is particularly interesting for design research. The W value from Kendall's W test rather roughly indicates the tendency, but it is quite practical because we can identify the strength of the relationship among more than two variables at once. When you first begin examining the relationship between two variables, it is important to visualize what the data look like. In Excel, it is easy to create a scatter plot of the two variables. The figure is an example of a scatter plot, and this shows the relationship between mean scores of science courses in x-axis and mean scores of ID courses in y-axis. Notice that as the mean scores of science courses increase, the mean scores of ID courses also increase. This is called as a positive relationship because as one variable increases, the other variable increases too. So the tendency is toward upward. So what do you get from this chart? Those who performed well or excellently during their freshman period also performed well after they joined our ID department. Therefore, based on the students' grade in science courses during their freshman, the department can quite directly predict their future performance after they have joined in our department. In KAIST, it is not allowed to screen the students, so we have to accept all students who have applied for our department. But this scatter plot implies a congruency or consistency of performance between before and after of starting the major courses. In addition, the dotted line runs through the data is called a trend line, or more statistically speaking, regression line. And this line helps you to better visualize the relationship between the two variables. So plotting your data in a scatter plot is just the first step. You also want to understand the degree of association between the two variables. This can be done by performing the correlation analysis. This is another example of a scatter plot. The x-axis indicates the lightness of a color and the lightness varies between 0 and 100. 0 indicates black and 100 indicates white. And the y-axis indicates the bitter taste associated from a color. So based on this scatter plot, we can identify that there is a negative relationship between the lightness and bitter taste. If we draw a trend line, either a straight line or a curved line, may be an idea. Therefore, we conduct a correlation analysis in order to describe the strength and the direction of the linear relationship between two continuous variables. The statistical significance of a Pearson correlation analysis is judged based on the Z value. Therefore, it refers to a normal distribution once you have the Z-score. And the Z-score of a Pearson correlation analysis is calculated through this formula. As you see here, you need to know this R in order to calculate the Z-score. The R, usually written in italic typeface, is a coefficient of the Pearson correlation analysis. The R is a ratio of covariance to the two standard deviations. They are here multiplied. As the variance of X is obtained through this. So the covariance of X and Y is obtained just by replacing X with Y. So instead of squaring the mean difference between X, you put the Y aspect. By doing so, you can calculate the covariance of X and Y. Therefore, the R implies the ratio of variability in both X and Y directions. So now you have the R, and you can calculate the Z-score. But as the formula shows, the Z-score is in proportion to the root square of the sample size. So somehow the Z-score is in proportion to the rooted square of the sample size. That's what we can observe from this formula. Therefore, when the sample size is small, the Z value will be small too. And a small Z value will lead to the result that the Z-score is not reaching to the critical Z value. This yellow curve marks the area of threshold. When the sample size and the R value belong to this shaded area, so under the curve, it is technically not possible to reach the statistical significance. This yellow curve is drawn when the alpha level is 0.05. When the alpha level is smaller than that, then the yellow line will be even higher than that. So the area will be increased. So more difficult to reach the statistical significance. By the way, the statistically not significant correlation means that the identified relationship is not yet confident. The strength or the direction of the relationship might have been occurred by chance. In fact, the R corresponds to the effect size of the Pearson correlation analysis. The R indicates how strong the relationship between the two variables is, and the R ranges from -1 to +1. And when R equals to +1, this indicates a perfect positive correlation. When R is -1, then it indicates a perfect negative correlation. And the strength of a correlation is, or it is suggested to be, interpreted with small when the absolute value of R is between this value. And the strength of the correlation is considered as medium size when the absolute value of R is between 0.3, sorry, it's a misspelling, to 0.5 or 0.6. In social science, my recommendation is to include 0.6 as medium size. And when it's bigger than 0.6, the absolute value is bigger than 0.6, then we can usually conclude that the strength of a correlation is large. The following 7 scatter plots describe different shapes of data clouds. More dispersed from here or coming from here, more dispersed from the trend line, smaller is the coefficient. When there is no trend identifiable, the coefficient is almost 0. Now let me demonstrate to you how we can perform the correlation analysis, so Pearson correlation analysis in Excel. First, it's two ways. Either you can use data analysis function or you simply type in the function because it's quite simple. So let's assign this cell to result the coefficient, and the function equals to and the first array is the lightness and the second array is bitterness. And I close here. Okay, so the correlation coefficient is almost minus 0.8, so there is a strong negative correlation between the lightness and the bitter taste associated from the color. But in Excel, we cannot yet conclude whether this strength or this correlation is statistically significant. So I tried also with the data analysis, which look more professional or So I clicked here, but before you conduct the correlation analysis using data analysis tool, you should rearrange the data. So I have to cut the bitter column and I have to move this bitter to here so that I can cluster them in such a way. Okay, so I consider that is it's not convenient though. So let's select the data range, and the first row is the label, and the output, let's generate the output from here. Okay, so the correlation coefficient is identical with what we just have seen, but here also that's not the statistical significance is not shown. So either you calculate the z-score using the formula you have seen in the slide, or you use SPSS. So I copied the data in Excel, and let me show you how we can perform the correlation analysis in SPSS. So analysis, and correlation analysis and bivariate. And here you can actually select all if you are still exploring any correlation which may exist unexpectedly. So we will test it later. So first, let me show you how we can calculate the correlation coefficient between lightness and bitterness. Okay, so it's quickly made, and the same size of a coefficient, but here the table presents us the two asterisks, which means the correlation coefficient is statistically significant at an alpha level of 0.01. And let's do the correlation analysis for the entire variables. So who knows, there is a different from different combinations there might be correlations too, and it's can be quickly generated, and it's a good idea to explore any potential relationships before you go into the analysis. So let's see here, the lightness, between lightness and bitterness, we already have calculated, and we know here lightness and sweetness. So when the lightness of color is increasing, then people feel more sweet from the color. And here, between these two tastes, there is a strong negative correlation. So when a color looks sweet, then it means it doesn't look very bitter. And spicy and A is actually the property of the redness of a color. So when a color is more reddish, then more spicy, people have felt. Yeah, it should be true. So in such a way, although your initial purpose is to analyze the correlation coefficient just between bitterness and lightness, but you also can explore different combinations, even between two taste types, and spiciness and the reddishness. So for exploring any potential relationships, I highly recommend you to perform the correlation analysis for all variables.